So we looked at different blocks. So let me revisit this picture again. Okay, this is one of the architectures that we discussed. So if you remember, there were two major things where I had written some letters. So this is the first one. This is on the transmit path, right? Transmit, I call it by TX. So this is the transmit path. This is the receive path. And you see another device here on the receive path called as LNA. So let's look at what is a PA and what is LNA. So PA is called as the power amplifier. So amplifier, we already discussed, the point of amplifier is to provide gain. So what do you provide gain for? So you have a certain signal level, right? That is all coming from all these paths. But there is a final power level. Let's say if we're talking about 5G or 3G, we're talking about 3GPP specification. So 3GPP will tell you how much power have to be transmitted from this antenna. So that final power level can be given by this PA. Okay, PA will give the final power level that is transmitted over the. What is the purpose? So what are the typical numbers? You can assume that whatever is entering the PA, okay, let's say it is in the range of 10 nanowatt or 1 milliwatt or something in this range. So what is the goal? The power amplifier increases it by 20 dB or 30 dB or basically 100 times or 1000 times. So you take 1 milliwatt, increase it by 1000 times. So okay, so this 30 dB or 20 dB is the gain of the power amplifier. We discussed about gain, right? P out by P in. We discussed about P output power by input power. So you basically are saying that you're taking a 10 nanowatt or 1 milliwatt range of power levels and increasing it to 1000 times or 100 times. Okay, so that is the gain of the amplifier. So mostly operated in linear. So if you remember this graph, you might have seen basically if you draw something like this, P in, P out versus P in curve. So as the power increases, input power increases. So this is the PA, right? This is P in, input power. This is P out. Okay, this is Y axis, this is X axis. So as the power increases like this, output power also increases. So that is linear. Okay, and like every diode or transistor, so these are all made of diodes or transistors. All are made of transistors, power amplifiers. So obviously it will, after a certain point, it will become non-linear. Okay, so the expectation is you want to operate in the linear region as much as possible. This is a power amplifier. Next, look at what is a LNA. LNA is a low noise amplifier. So this is a device on the receiver side. So I showed you here. This is a device on the receiver side. So why is it called low noise amplifier? So if you remember in the noise figure or the noise factor discussion, I told you every device adds noise. Okay. So, and I also told you, if you look at the transmit signal, the receive signal is very small. Right? This is a very small level signal. So there are two things that I have to do. From the antenna, I get the receive signal. Okay. So there are two challenges or the two goals. First goal is this low level signal of Rx, I have to amplify it. Okay, so that rest of my circuitry here, right, rest of the circuit should be able to process that signal. So first thing is I have to amplify the signal. So that's why it is a amplifier. Second thing is, since every device adds noise, and this is the first block, and also the Rx power is so low, you don't want the LNA to add too much noise. Okay. See, first of all, your signal level is so small. Now, if you add noise on that, your signal level will further get buried. Okay, that means the rest of the circuitry cannot even find the signal because first of all, it was low and LNA also added noise. So you want the amplifier which is low noise. So power amplifier is not low noise. Okay, it has high noise figure. So you want a LNA or an amplifier which is low noise figure. Okay, you call it as low noise figure. Low noise figure amplifiers are called as low noise amplifiers. Okay, this is what I said. So you can see what are the typical power levels that are entering the antenna of a receiver. It can be 10 to the power of, femtowatt. Femto, if I remember, let's see, pico femto minus 15 watts. Okay, nano is 10 to the power of minus 9 watts. So these are the power levels in the receiver. So see, it almost looks like noise. It is so low. Okay, this is the expectation of the LNA. So LNA is mostly the first device in the receiver because it has to provide gain while the same time it should not add noise.
Please click on like and subscribe to our channel and click on the bell icon for regular updates.